So this is the ninth video on rigid body kinematics. This is a continuation of the eighth video. So in this we take up the numerical problems on SRC procedure for velocity. SRC procedure. SRC procedure details you'll get in the eighth session. So before going to ninth session, you must definitely watch eighth and ninth, seventh and eighth video. Then you must come to this one. Okay. So you definitely before, if you don't know the theory and you come to this new session, you won't understand it. So you must definitely know the contents theory of this numericals of this video by referring to 7th and 8th video on rigid body kinematics. Okay. So this I'll take up numerical questions on SRC. So I'll write down the question I'll take up. Okay. Question is this. M is a rigid rod. M is a rigid rod which rotates of length 2 meter. M is a rigid rod of length 2 meter which rotates in a vertical plane with respect to ground with an angular speed omega. P1 and P2 are the two material points of the rod. Two material points of the rod. In each case, V1, G and omega are specified. We have to find V2G, question mark. We have to find V2G, that is the question mark. V2G has to be determined. V2G has to be determined, okay. So now I'll take up question one by one, okay, fine. Part A. Part A is this. So in all these problems, solution, instead of F we'll have the ground frame denoted by G. Instead of M we have the rod frame. Length of rod is given to be 2 meter. It's undergoing a plane motion in the vertical base plane. Its base plane is vertical. Rod is confined to rotate in a vertical plane. So for part A, so we have to V1G means velocity of P1 with respect to ground, and V2G is the velocity of P2 with respect to ground, which we have to find. V1G is given, omega is given, magnitude and sense both. Okay. So part A, see part A of the question. So this is point P1, this is point P2. Length of the rod is given to be 2 meter. Sense of omega is clockwise, say 4 radian per second. Omega of rod with respect to ground is 4 radian per second in clockwise sense. Velocity of P1 with respect to ground is 3 meter per second, like this. Now we have to find the velocity of P2. Okay. So we have to apply the SRC procedure for velocity. So we follow the rule. Details of SRC procedure has been given in the 8th video. You can see that, you'll get here. So first of all, you decide the selected point. SP meaning selected point. P1 is the selected point, double-headed arrow. P2 is the other point, OP arrow, P2. Okay. Now, first, what action we have to take? We draw the line joining SP and OP, whose orientation is same as in the problem. Orientation is vertical, so this line is also vertical. So, we give the velocity of SP to OP. Velocity of SP is 3 rightward to 3 rightward at right angles, right angles. First action we have taken. The second step is rotation term. Now sense of omega is clockwise. So according to that theory, P2 moves in a clockwise circle with center at P1 and radius 2, whose angular speed is 4 radian per second. So we gave a speed of omega r into r, 4 into 2, 8 meter per second. Right angle to this line P1, P2 corresponding to sense of omega. So For clockwise motion, circular motion, it should go right side. Omega r. So 4 into 2, 8 meter per second. Now third step, combination. We have to vectorially add these two to get the velocity of P2G. P2 with respect to ground. So V2G becomes 8 plus 3. It becomes 11 meter per second in rightward direction. This is therefore the required answer. Okay, fine. Clear? This I'll rub it now. So part B, next part of the question, part B is this. This is P1, this is P2, length of rod is 2 meter. Velocity of P1 is rightward, ground with respect to ground, 5 meter per second. Omega of rod with respect to ground is omega anti-clockwise sense, equal to say 4 radian per second. Length of rod is 2 meter. We have to determine the velocity of P2 with respect to ground. Again, we apply the SRC procedure for velocity. SP arrow P1. Here I do a double-headed arrow. That's not necessary. You can note like this also. OP arrow what? P2. Now, what action we have to do first? We draw the line joining SP and OP. That is this line. This is P1. This is P2. Orientation is same as in the problem. Vertical. The rod is also vertical. We give the velocity of SP to OP. This is SP. This is OP. 5 we give to right side. To P2, 5 meter per second, write this one. Now we write down the sentence. Omega is anti-clockwise. OP, that is P2, SP P1. So P2 moves in anti-clockwise circle with center at P1 and radius 2 meter, omega 4 radian per second. So if P1 is the center, P2 should move in anti-clockwise circle whose center is at P1, radius 2 meter. We should give omega r 4 into 2, 8 leftward, then only to anti-clockwise circle. So it is 8 meter per second in leftward direction. The next third step is combination. Velocity of P2 with respect to ground is the vector sum of these two. So V2G, they are in opposite directions. From parallelogram law of vector addition, we have to add these two. This becomes 3 meter per second in leftward direction. This is therefore the required answer. Is it alright? Clear? Fine. Now you have this one. Part C is this. Part C is this. This is a rod, 2 meter. This is P1, this is P2. Okay. Omega is again say 3 radian per second clockwise with respect to ground. Velocity of P1 is 10 meter per second rightward. Okay. Now I have to find the velocity of P2. V2G has to be found. V2G is the question mark. Now to find V2G, we again apply SRC procedure for velocity. So first we decide SP, selected point is P1, other point is P2. We draw the line joining SP and OP. Rod is vertical, so rod this vertical line. This is SP P1, this is OP P2. Then we give the velocity of SP to OP. Velocity of SP is 10 meter per second rightward. So we give velocity of P2 10 meter per second to P2 rightward. Okay. 10 meter per second rightward. Now we write down the sentence. Omega is clockwise, OP is P2, SP is P1. So P2 moves in a clockwise circle with center at P1 and radius 2 meter. Now if P1 is center, P2 is moving in a clockwise circle, omega is clockwise. Omega should be in which direction? Leftward. See, this is the center. P2 is moving in a clockwise circle with center at P1. We should give a velocity of omega r to P2. Omega r will be how much? 3 into 2, 6 meter per second. Now P1 center, P2 moving in a clockwise circle. So for this, omega r should be leftward directed. Omega r will be how much? 3 into 2, 6 meter per second. Okay. Now third step is combination. Velocity of P2 with respect to ground is the vector sum of these two terms. 10 rightward, 6 leftward. 10 minus 6, that is how much? 4 meter per second. And this is better. It is direction rightward. This is the required answer. So this second step is very important. Second step, you must remember, it's very important. Okay. The second step is, many students will make the mistake, they'll give omega r in rightward direction. No, it should be in leftward direction. Then only P2 will move in a clockwise circle. See, omega is clockwise. So P2 will move in a clockwise circle, whose center is at P1 and radius is 2 meter. So for clockwise circle, omega r should be 6 meter per second, should be leftward. Now velocity of P2 with respect to ground is the vector sum of these, that is 4 meter per second rightward. Okay. This also I'll rub it. Now part D of the question is this. This is a rod P1, P2. P1 is velocity of P1 is say 17 meter per second. Length of rod is 2 meter. Since omega is anti-clockwise, 6 radian per second. This is at right angles. Now to find the velocity of P2 with respect to ground, V2G has to be determined. Now again, we will follow the same procedure. We take SP arrow P1. So we take the P1 as SP, or SP arrow P1, okay. OP arrow P2. SP arrow P1, OP arrow P2. We draw the line joining SP and OP, whose orientation is same as in the question. Orientation of P1, P2 is vertical. So this line is also vertical. This is P1, this is P2, okay. Now we give the velocity of SP to OP. Velocity of SP is 17 rightward. So P2 also we give what? 17 meter per second rightward. Okay. Now we write down the sentence. Omega is anti-clockwise. So OP, that is P2, moves in anti-clockwise circle with center at P1 and radius 2 meter. So we give a speed of omega r 6 into 2, 12 meter per second. Now P1 is center. P2 moving in anti-clockwise circle. P2 is here. Omega r should be 6 into 2, 12 should be rightward direction. So we give a speed of 12 meter per second in rightward direction. The velocity of P2 with respect to ground is the vector sum of these two. So V2G is equal to 12 plus 17, that is 29 meter per second, that is in the rightward direction, and is therefore the required answer. Is it alright? So velocity of P2 with respect to ground becomes 29 meter per second in rightward direction. Okay, the velocity of P2 with respect to ground becomes 29 meter per second in rightward direction. Is it alright? Fine. Now I'll wrap this one. Party is this, party of the question. These are rod P1, P2. Length of rod is 2 meter. 2 meters the length of the rod. Angular speed of rod with respect to ground omega 4 radian per second clockwise. Velocity of P1 with respect to ground is 10 meter per second at an angle of 60 degree with the vertical with the rod. We have to find V2G. Okay, again we follow the same procedure. SP arrow P1, OP arrow P2. Fine. Now we draw the line joining SP and OP vertical. So this is also vertical line. This is P1, this is P2. Now we give the velocity of P1 to P2, SP to OP. SP is this, OP is this. We give 10 meter per second to OP at 60 degree angle. 10 meter per second at an angle of how much? 60 degree. Now we write down the sentence. Omega is clockwise, omega is 8 meter per second. We give a speed of 8 meter per second. We write the sentence. P2 moves in a, omega is clockwise. P2 moves in a clockwise circle. We center at P1 and radius 2 meter. So we give a speed of 8 radian per second. Now P1 is center, P2 is moving in a clockwise circle. So omega it should be rightward direction. They only to be clockwise circle. 8 meter per second. Is it alright? Now this is 60 degree, this is 90 degree, so this becomes 30 degree. Now third step combination. Velocity of P2 is the vector sum of these two. V2G becomes root under 8 square plus 10 square plus 2 into 8 into 10 into cos 30 degree. Cos 30 degree becomes root 3 by 2. So 2 goes away. So this becomes 164 plus 80 root 3 meter per second. That is the required answer. Is it alright? So velocity of P2 with respect to ground becomes root under 164 plus 80 root 3 meter per second. 164 plus 80 root 3 meter per second. That is the velocity of P2 with respect to ground. Now direction of V2G can be found from that vector concept. So that you can leave because we are just interested in magnitude. In the previous ABCD, we found the direction also because that was obvious by inspection. But here you have to calculate. So you can leave that, okay. This magnitude is to be calculated. Fine. I'll grab this first column. Now I take one more question, part F. Part F also I take part F. Part F is this. This is the rod P1, P2. This is the rod P1, P2, okay. P1, P2 is the rod. 2 meter is the rod length. Velocity of P1 is say 10 root 2 meter per second at an angle of 45 degree. And omega is this. 6 radian per second in anti-clockwise sense. Again, this is V1G. We have to find V2G again. V2G is to be determined now. We have to determine the value of what? V2G. Again, we apply the same procedure as we have been doing. We decide the selected point. SP arrow P1, OP arrow P2, OP meaning other point, SP meaning selected point. We draw the line joining SP and OP whose orientation is same as in the question. So this is SP P1, this is OP P2. Now we give the velocity of SP to OP. SP velocity of SP is 10 root 2, 45 degree angle. This we give to P2. 45 degree, this becomes 10 root 2 meter per second. Now omega is anti-clockwise, omega R becomes 12. Omega is anti-clockwise, so what sentence will write? P2 moves in anti-clockwise circle whose center is at P1 and radius is 2 meter. So for P2 to move in anti-clockwise circle with center at P1, omega R should be leftward. That is 12 meter per second should be leftward. So this is 12 meter per second at right angles. Okay. Now velocity of P2 with respect to ground is the vectors of these two. Third step, combination step. So V2G becomes root under 12 square plus 10 root 2 whole square plus 2 into 12 into 10 root 2. This we are adding using the parallelogram law of vector addition. And this angle becomes 90 plus 45, 135 degree. Cos of 135 degree it becomes. That becomes root under 12 square becomes 144 and this becomes 200. This becomes 24 into 240 root 2 into minus 1 by root 2. So root 2 goes away. So this becomes 344 minus 240. This becomes 104. 24 into 240. Okay. So this becomes 344 minus 240. That becomes 104. Root 104 meter per second is the required answer. Alright. So velocity of P2 with respect to ground becomes root 104 meter per second with respect to ground. That is therefore the required answer. Alright, fine. This also a rabbit. I take one more question. This is like this. This is a rod. This is P1, P2. Length of rod is 2 meter. Omega of rod with respect to ground is clockwise 4 radian per second. With respect to ground, clockwise omega. Velocity of P1 with respect to ground is 20 root 2 meter per second. 45-degree angle. Now we have to again find V2G. Again, we follow the same rule as we have been doing in this video. So, SP arrow watt P1, OP arrow watt P2, SP arrow P1, OP arrow P2. We draw the line joining SP and OP. Orientation is same as in the question. Line P1, P2 has been drawn. We give the velocity of SP to OP. Velocity of SP is 20 root 2 45-degree angle. This we give to P2. 20 root 2 meter per second, 45-degree angle. Now we write down the sentence. Omega is clockwise, R is 2 meter, omega R becomes 8 meter per second. Sentence will be what? P2 moves in a clockwise circle whose center is at P1 and radius is 2 meter, omega is 4 radian per second. So what speed we must give to P2? 4 into 2, 8 meter per second. Now for clockwise circular motion, P2 should go left because this is the center. P2 is moving in a clockwise circle. So P1 is center, P2 to move in a clockwise circle, P2 should go leftward, omega should be leftward direction. Omega will be 4 into 2, 8 meter per second. This is right angle. And third step, we vectorially combine these two velocities to get the net velocity of P2 with respect to ground. So V2G is the speed of P2 with respect to ground. From parallelogram law of vector addition, this is sum of these two terms. It is equal to root under 8 square plus 20 root 2 whole square. 2 into 8 into 20 root 2 into cos 3 pi by 4. Angle becomes 90 plus 45, 135 degree. Cos 135 degree becomes minus 1 by root 2. And root 2 goes away. This becomes how much? 64 plus 800 minus, this becomes 160 minus 320. Is it clear? Okay. So this becomes how much? This becomes 864 minus 320. 324, 4, 5. Root 544. Root 544 meter per second is the required answer. The velocity of P2 with respect to ground becomes, root 20 root 2 meter per, root 544 meter per second. This you can simplify further, you leave it like this, there is no harm. Okay, fine. I'll rub this also. I take one more question. This is a rod P1, P2. Length of rod is 2 meter. omega of rod with respect to ground is 8 radian per second anti-clockwise sense. Velocity of P1 with respect to ground is 20 meter per second. Okay. So say at an angle of say at an angle of say 60 degree and 30 degree. Okay. Omega is 8 radian per second. 2 meters the rod length. Velocity of P1 is this much at 30 degree angle with the rod. Again, to find V2G, velocity of P2 with respect to ground. Okay. How to, again we use the same procedure. SP we decide to be P1. OP we take to be what? P2. SP arrow P1, OP arrow P2. Then you draw the line joining SPOP, vertical, so here also vertical. P1, P2. Now we give the velocity of P1 to P2. Velocity of P1 is how much? 20 meter per second at 30 degree angle. This velocity we give to P2. 20 meter per second at an angle of how much? 30 degree. Okay. Now sentence we write. Omega is anti-clockwise. R is how much? 2 meter. So omega R becomes 16 meter per second. Omega is anti-clockwise. So P2 moves in anti-clockwise circle. Whose center is at P1. Radius is 2 meter. So for P2 to move in anti-clockwise circle with center at P1, omega R should be in rightward direction. Then only anti-clockwise circle it will be. Omega R 8 into 2. 16 meter per second. Okay. This is 90 degree. And third step we have to combine them. Net velocity of P2 is the vectors of these two velocities. V2G becomes root under 16 square plus 20 square. 2 into 16 into 20 into angle becomes cos 120 degree. Angle becomes 120 degree. So cos of 120 degree. Now this becomes how much? Root under 16 square becomes how much? 256. 16 square is how much? 256 plus 400 plus this becomes 32 into 20, 640. Cos 120 becomes minus half. Okay, fine. So this is simplified. You get the velocity of P2 with respect to ground. This are a bit okay. So this becomes how much? So on simplifying, V2G becomes how much? Tell me. This becomes root under 400 plus 256 becomes how much? 656. Minus what? 320. Okay, fine. So this becomes how much? 320, 340, 336. 336, yes. Root 336 meter per second, which is therefore the required answer. So V2G becomes how much? Root under 336 meter per second is therefore the required value of V2G. Root 336 meter per second is the required answer. Alright, fine. So this was the 9th session on rigid body kinematics. So I've discussed, basically I've discussed one question, but there are 8 subparts, okay. So in this application of SRC has been discussed in great detail, okay. So in coming few sessions also we'll take up problems on this SRC procedure for velocity. Then we'll take up questions on rolling motion, okay. Rolling with slip, rolling without slip, all such things we'll take up, okay. This I close it here, fine, alright.